Good afternoon, everyone. The second session of today's program is entitled Nature, the Architecture Between Ecology and Landscape. During the 20th century, new design practices have developed that place respect for the environment and its diversity as a spontaneous and non-negotiable necessity. Numerous architects have moved in this direction, proposing on one hand forms of environmental mimesis, and on the other reflecting on the very limits of architecture, up to hypothesizing ecological version of minimal impact. Alongside these are practices linked to technical and material sustainability, such as the Ego to Eco project by the Studio Effect, the ephemeral fog building pavilion by Diller and Scofidio, Renzo Piano's Biosphere, and the architectures of Marina Tabassum, whose design language is attentive both to climatic changes and to the rooted culture of the place, its materials and traditional techniques. In his book, The Architecture, Paolo Portoghesi highlights the exceptionality of Frank Lloyd Wright's work for its lesson on space, matter, and energy. For Wright, matter is not static, but part of a process, a cycle in continued change. Architecture, likewise, is not an isolated object, but a field of energies in relation to its context, and it will also be defined by scientists and physicists such as Einstein, Prigogine, Whitehead, and Beatson. The challenge then lies in the connection between ecology and landscape, a return to original knowledge, to matter and its relation, accompanied by the awareness that every human intervention modifies a pre-existing balance. The guiding question of this session is, which scientists and which architects have charted and are still following this path? To what extent can architecture venture even into the realms of knowledge hybridization between science, art, and technologies to rediscover a profound relationship with the earth, without ceasing to be architecture, but pursuing its ethical, social, and environmental vocation? So now we can start with the first speaker. We remind you that each presentation will last 20 minutes. Questions will be taken at the end of the session. And now I introduce the first speaker, who is Max Boutel from Maastricht University. And the first talk is entitled Alexander Pike and the Population Bomb Shelter. So Max, please.
Thank you so much. I have a PowerPoint, and which I imagine if I share it, you'll be able to see it.
Yes.
Is this visible to everyone?
Okay.
You can see this?
Yes.
Perfect. So, yeah, first of all, my apologies for not being there in Pisa. My wife and I are expecting a baby any time now. And I wanted to thank the Weird Science team for facilitating my participation and ensure everyone that the subject of this talk has nothing to do with my upcoming parenthood. Today, I'm going to be talking about the architect Alexander Pike. To date, the limited scholarly attention given to Pike has focused entirely on his autonomous house project. And given the state of the literature, I think it makes sense for me to begin at the end and introduce Pike through the project, which would ultimately define his career. But before doing so, perhaps it's useful to ask, what is an autonomous house? Well, autonomous houses are generally defined by their self-sufficiency, that is, their partial or total independence from the material, political, and/or social infrastructures upon which modern high-performance buildings are typically dependent. In the case of Pike's autonomous house, which is actually the one illustrated on the left there, autonomy was understood as autonomy from network services, namely electricity, gas, water, and sewage. This project did initially seek some degree of self-sufficiency in food as well, but this is to say that it was largely disinterested in political autonomy, and it was later rebranded the Autarkic House project to sideline these political connotations. The project lasted from 1971 to 1979, and the house was never realized. The project is considered groundbreaking, though. Unlike comparable countercultural projects, the house sought to deliver the material standard of living expected of the average British householder. But to deliver this year-round was quite the challenge, especially given the British climate. It necessitated the development of a really complicated integrated system where energy was generated from multiple renewable sources and, when possible, stored. To this end, the team deployed solar technologies, harvested methane from recycled human waste, and developed a wind turbine fit for use in a single-family home. Given all of the above, it would be really easy to pigeonhole this as an example of visionary eco-architecture. And in some senses, this is correct. But having spent time looking at Pike's papers, I came to realize that the motivations underlying this project were considerably more complicated. So, in keeping with the session's themes, I want to explore the meeting of environmental science and architectural design, and the interplay of ideas, enthusiasms, and anxieties which gave shape to the autonomous house. And I'll do so by means of a portrait of the project's director, Alexander Pike. So Pike was born in 1924 and entered practice in 1951 with Archon. Archon are actually Britain's most storied manufacturers of prefabricated architecture. And Pike's enthusiasm for and frustration with the state of industrial building is most explicitly outlined in his 1956 thesis. This begins on a nationalistic yet state-skeptic note, announcing that the land fit for heroes has deteriorated into a bitter and ironic joke, before going on to lobby for the development of non-traditional methods in industrial architecture. Pike was deeply distrustful of the architectural establishment, who he accused of failing to build houses of a sufficient quality and quantity. Pike held that prefabrication could address this persistent national housing shortage, but found that existing methods tended towards an oppressive uniformity. Consequently, he prioritized the development of cost-effective and flexible building systems, which could be adapted and even relocated, and thus remain sensitive to each family's unique pattern of life. And this commitment to greater flexibility even leads Pike to hypothesize an architecture liberated from the tyranny of the underground system of pipes. He met like-minded radicals when he joined the experimental design unit of Taylor Woodrow in 1961. Here he worked alongside the newly founded Archigram Group, and both Theo Crosby and Robin Middleton, who were the former and future assistant editors of architectural design. Pike almost went into practice with Archigram's Ron Heron and Dennis Crompton after the unit disbanded, and he'd contribute to architectural design in various capacities until his death, during which time it emerged as a key forum for this second generation of the British neo-avant-garde and alternative technologists alike. At architectural design, he's best remembered for Product Analysis, a series of articles written on the history and future of architectural fittings. This series was written in the conviction that radical transformations of the sort of architecture acceptable to the everyman rested foremost in developments in reproducible components. In these articles, Pike again stresses that transformations in ordinary architecture, of the sort unseen since the Victorians, would require architects to think through how buildings might become detached from main servicing. In 1969, he then landed two significant jobs. The shorter-lived of these saw him posted in Lima to advise on construction techniques as a part of the UN Development Project's PREVI scheme, which aimed to provide non-traditional architectural solutions to problems associated with Lima's rapid urbanization and these informal squatter communities which had developed. Pike's unrealized solution was the minimum house. I don't have images of this, unfortunately, but it was designed with a prefabricated core modeled on small boats and caravans, and was, designed to enable easy upwards extension by means of DIY. He even envisaged a UNESCO-funded Institute of Industrial Design, elsewhere described as an Andean Bauhaus, which was to be charged with its design and manufacture. But Pike felt unable to effect change at the United Nations and decided to focus on his new role at the Department of Architecture at Cambridge University. In 1970, he established the Technical Research Division, which was dedicated to the study of industrial building as it related to the problem of the relationship between man and his environment, and in turn, the interrelated problems of population, planning, food, energy, and pollution. But how was their relation understood? Well, for Pike, like many others grappling with these questions in the late 60s and early 70s, the priority of population was clear. Population growth was understood as a root cause and multiplier of all related problems. And though the birth rate in countries like Britain was not actually especially concerning, Pike was writing at a time of increasing migration to Britain from its former colonies. He noted that the population doubling rate was as low as 20 years in some undeveloped countries, and warned that if Britain ignores this problem now, it would lead to serious problems in the future. But how could an architect respond to the population dilemma? Well, one facet of Pike's response was to relieve increasing demand for scarce resources. The autonomous house would forego energy sources indispensable to most other architectural models. Pike even argued that it would abate a forthcoming struggle over land, as the small farming plot initially incorporated into the scheme promised to be farmed with far, far greater efficiency than large, land-intensive industrial farms. Though these innovations could counteract trends towards increasing demand for increasingly scarce resources, they were only part of a more holistic reaction. Pike was keenly aware that many of the issues associated with overpopulation, such as problems with pollution, land values, crime rates, other social and nervous disorders, are greatly compounded by the tendency of these ever-increasing populations to cluster in increasingly dense urban centers. But the house's recourse to ambient energies and its recycling of waste enabled it to be independent of main servicing, and Pike liked to stress that such a house might be, within reason, located anywhere in the world. And in this way, autonomy and self-sufficiency were prerequisites for what Pike called planning freedom. High-performance autonomous architecture would disincentivize accretive urban growth, where new houses were, almost by default, plugged into the increasingly strained services of ever-expanding urban centers. So by facilitating a more even distribution of residential units across the country, the autonomous house relieved precisely those pressures Pike associated with overpopulation. But the autonomous house was not solely motivated by a concern for population pressures. Pike held long-standing grievances with the architecture and urbanism of post-war Britain, and the autonomous house addressed many of these grievances. To take only one example, Pike regularly took aim at post-war urbanism, arguing that few examples of post-war planning had created anything better than the best examples of uncontrolled or randomly planned towns. The idea of planning freedom then also represented a return to a less determined approach to urban forms. The autonomous house was the basic architectural unit of a more spontaneous planning regime, one situated in opposition to that of the heavy-handed and high-modern estates. And as in Britain, Pike held that autonomous housing provided an alternative to urbanization in countries like Peru. When making this point, he often noted that the dwellings of natives were themselves often effective autonomous houses, and far, far preferable to the terrible conditions of those in Lima's squatting communities. The autonomous house then addressed this perceived crisis of overpopulation in a manner which reflected Pike's grievances with architecture, planning, and urban life in Britain, and to a lesser extent Peru. But the 1973 oil shock provided the team with a new context against which they could situate and justify their research. and they increasingly emphasized the house's material benefits with regards to its innovative use of energy. Again, the autonomous house was always intended to maintain a level of performance in keeping with the expectations of the everyman. But following the oil shock, the relevance of a high-performance house built on alternative technologies became clear. The autonomous house would be unaffected by recurrent strikes and power cuts, which, Pike argued, transformed the most highly serviced houses into something very primitive. And this commitment to preserve standards of living put him at odds with other champions of alternative technology. Pike was only willing to tolerate those alterations to established lifestyles which were deemed absolutely necessary to make autonomous housing viable. And he regularly dismissed the emotional, poetic, or romantic motivations of the so-called eco-freaks engaged in similar pursuits. And though this attempt to mainstream alternative technology was actually initially quite successful, waning concerns for overpopulation and the production of North Sea oil from 1975 onwards would have increasingly deprioritized the project on its own terms. And it's from this point onwards that we see in the papers that the funders are growing increasingly impatient with the project's slow progress. The sudden death of Alexander Pike coincided with a funding crisis, and the project was completely abandoned in 1979. Ultimately, the Technical Research Division, that was incorporated into the Martin Centre at Cambridge University, which to this day remains a key centre for research into sustainable architecture. And several researchers who did their PhDs on the project would have similarly distinguished afterlives. Ken Yang is today a preeminent ecological architect and the major theorist and practitioner of bioclimatic design. And Brenda and Robert Vail became the major proponents of autonomous architecture into the 80s and 90s. But they never lost an interest in alternative solutions to the population problem. As late as 2009, they co-authored Time to Eat the Dog, a book which highlights the carbon pawprints of our pet populations. And the couple later lobbied for a municipal ban on all non-edible pets on environmental grounds. So, to begin wrapping up, I'd like to begin by noting that Alexander Pike was not alone in believing that population growth imperiled the relationship between man and his environment. Thomas Robertson has already evidenced the close affinity between post-war American environmentalism and Malthusianism. Malthusianism is the theory that exponential population growth, when combined with scarcity or linear growth in essential resources, poses an existential threat to humanity. Though Malthus was writing at the end of the 18th century, these ideas were subject to a revival of sorts in the mid-20th century, becoming popular currency when the recently deceased Paul Ehrlich published The Population Bomb in 1968. Nor was Pike alone in believing that population growth placed particular pressure on urban centers. Robertson shows that American Malthusians regularly associated population growth with squalid inner cities and sprawling soulless suburbs. Though many of the most immediate problems were then recognized as urban, interventions in architectural and urban design do not figure in Robertson's account. The case of Alexander Pike demonstrates that architects did engage with and attempt to find architectural answers to the population dilemma. But the autonomous house was not purely driven by Pike's concern for overpopulation. Rather, population connected a series of long-standing concerns and brought them together in an ecological project. Pike was a skeptic of post-war housing and urban policy, a jobbing avant-gardist who upheld the unrealized potential of industrial techniques, and a man concerned for those seduced by the rapidly expanding urban centers of the underdeveloped world. Though he repeatedly lobbied for a research program which connected these concerns, both their ultimate synthesis and orientation towards environmental questions only followed from Pike's attempt to theorize an architecture appropriate to an overpopulated world. In time, the project was increasingly justified through reference to its innovative treatment of energy, and the Technical Research Division and some of its former members would go on to establish themselves as key players in the greening of architecture. Viewed in this light, the origins of this green architecture appear considerably more ambivalent than they're often assumed to be. Existing research has already muddied understandings of the ecological architecture of the 60s and 70s, often portrayed as examples of groovy science or hippie modernism, instead highlighting their relation to big scientific and industrial concerns. The case of Alexander Pike evidences that these often avant-garde projects were not immune to popular anxieties. The autonomous house was devised as an architectural response to Malthusian concerns, which were, in turn, connected to intractable struggles over land and resources, destabilizing flows of migrants into Britain, overcrowding, and social and network services strained to the point of collapse. In this way, Pike associated global population growth with a set of issues more commonly associated with the inner city. Over the course of the 60s, Britain's inner cities had emerged as a focus for increasing anxiety and demonization within political and media discourse. Historians have shown that the inner cities were both a locus for disillusionment with the project of urban modernism and understood as sites where established ways of life had come under assault. Not only did Pike's framing of the population dilemma mirror these concerns, he sought to directly address them. The idea of planning freedom was to offer a spontaneous, low-density alternative to the overdetermined urbanism of the high modern state. Meanwhile, the house was intended to preserve, as far as possible, this established way of life and the nuclear family's material standard of living. So returning to the themes of this panel, this contribution suggests that the historiography of ecological and sustainable architectures would benefit from a closer engagement not only with questions of population, but also with research into popular sentiments towards the built environment. In Britain, researchers working at the intersection of architectural and social history have repeatedly demonstrated that urban transformations, more typically ascribed to global processes and visionary architect planners, were often negotiated, contingent, and effected from the bottom up. As a panel grappling with visionary projects responding to environmental transformations, our accounts cannot afford to neglect global processes or individual ingenuity. Yet, the case of Alexander Pike demonstrates that both the interpretation of these environmental processes and the design interventions which sought to address them might still be deeply marked by popular anxieties. Thank you so much for listening. Really appreciate it.
Second presentation is by Clemens Finkelstein from Munich University, and he will present a talk entitled Alien Earth, Architectures of Non-Human Intelligence.
Great, thank you so much. First of all, thank you very much to the organizing team behind Weird Science Isolated Intelligences. Many thanks to Lina for putting up this really fascinating and really high quality symposium so far. Let's see if we continue with my presentation, because I have a couple of disclaimers. First disclaimer to the session chairs: I kind of substantially rewrote the paper on my way to Pisa yesterday, so I hope it still makes sense, so let's see how it goes. And the other thing, just that this is like a really, really new project, and I just began to think through this because of the prompt of Weird Science and Isolated Intelligence, because this idea of intelligence and non-human intelligence has been something that I've been like really fascinated with in the last couple of years, and so this is kind of like an attempt to kind of like bring this into my own field of architectural history and theory. All right, so let's begin. Imagine a cylindrical room, 40 meters tall and nearly as wide, lined with 11,000 golden hemispheres. This architecture is not designed for human beings. It is designed for neutrinos, particles so indifferent to ordinary matter that trillions of them pass through this very lecture hall, through your hand, through the earth itself. The golden hemisphere that lines this place are photomultiplier tubes, each a 50 centimeter artificial eye waiting for the faintest flash of Cherenkov radiation. Light produced when, occasionally, a neutrino deigns to interact with a molecule of water. Carved a kilometer into a mountain in central Japan, Tsupakamiyokonde is one of the most extraordinary architectures on Earth, built for an encounter with something utterly alien. This paper examines such buildings, architectures designed not for people, but for particles, gravitational waves, and forces that operate at scales and speeds radically other to human experience. Architecture as a discipline has well-developed frameworks for thinking about how buildings relate to their human users: program, typology, spatial experience. But something strange happens at the edges of contemporary science, or maybe something weird happens. Consider a building whose entire program is the detection of forces invisible to human senses. It descends underground, evacuates its interior, filters out every stray particle and vibration. It refuses the very environment conventional architecture seeks to mediate. Its inhabitant is not a human user, but a signal. Its program is calibrated to phenomena no human physiology can perceive, to the cognitive thresholds of matter itself. Such structures demand a different question and a different method, maybe. Not how buildings house bodies, but how they attune environments to forces, not what they enclose, but what they render perceptible. They invite us to theorize architecture less as a container for human life worlds than as a part of the experimental apparatus itself. Build environments that do not merely house an instrument, but are one. Every material decision in these buildings is, at the same time, a structural and an epistemic one. A brief detour by way of provocation. I borrow my presentation's title from Noah Hawley's TV series Alien Earth, and with it a scenario the Alien franchise has staged for nearly 5 decades. A built environment overwhelmed by matter it was not designed to accommodate. What interests me is not the iconography, but the structural problem. How does architecture confront matter that operates according to logics radically other to human life worlds? The observatories I will examine answer this question in a way the franchise never imagines. They do not collapse before the alien, they reorganize themselves to attend to it. This entanglement of building and instrument is not new. In Mechanization Takes Command from 1948, Siegfried Gideon proposed an anonymous history of the 20th century. The slow infiltration of mechanical operations into the kitchen, the slaughterhouse, the office. Mechanization, he argued, is not a layer added to architecture from outside, but a logic that rewrites the building from within, dissolving all the distinctions between apparatus and envelope. The observatories I describe extend this trajectory to its limit. In them, mechanization has not merely entered the building has become the apparatus. Gideon's insights finds a parallel in work that emerged from a different direction. Beginning in the late 1990s, historians and sociologists of science argued that the spaces of knowledge production are not neutral containers, but constitutive of the knowledge they produce. That where science is made shapes what counts as scientific. At planetary scale, this claim takes its strongest form. The object of knowledge itself, a global climate, a planetary system, exists as a scientific object only because of a distributed apparatus of stations, sensors, and computational systems was built to register it. This is Paul Edwards' argument in A Vast Machine from 2010, and it informs this paper's thesis in a compressed form. To know the alien is already to have built something. What this literature has not yet fully addressed is the threshold beyond which the buildings where knowledge is made ceases to be a space for human researchers and becomes the instrument itself. The first of my 3 cases, ascending above the atmosphere, is the most familiar. The high-altitude observatory has a long lineage. The 2 that follow are stranger, descending 1 kilometer into the Earth and extending 3 kilometers across the plane. Together, they push the building as instrument argument to a new scale, recruiting the planet itself its atmosphere, its lithosphere, into an apparatus for attending to the cosmos. Yet across this literature, architecture remains the setting for cognition. The buildings I examine require different formulation. From the architectural side, mechanization is no longer something that happens to the building. The building itself becomes the The buildings I examine require a different formulation. From the architectural side, mechanization is no longer something that happens to the building. The building has become the apparatus. From the history of science perspective, the laboratory is no longer the site of an experiment. The building is the experiment. 3 buildings will carry the argument. A high-altitude solar observatory in the Colorado Rockies, the most familiar of the 3 maybe, a neutrino detector 30 kilometers beneath central Japan, and a gravitational wave interferometer on the Tuscan Plain just kilometers from this room. At climax, the coronagraph cannot function apart from its built environment. The observatory's elevation, orientation, and thermal mass are what make the observation possible. In the 2 cases that follow then, the distinction collapses entirely. Super Kamiokande cylindrical tank does not house a detector, it is one. Virgo's 3-kilometer arms do not support an interferometer, they are the interferometer. This collapse generates what I call operative disconnectivity, a mechanism by which the building produces knowledge of our alien planetary condition by simultaneously disconnecting from the conditions it seeks to register and connecting to them through that very withdrawal. I read these buildings through 3 architectural strategies: ascending, descending, and extending. I begin with the most legible of the 3, the case where the collapse of building instrument is maybe easiest to see. In 1940, the young astronomer Walter Orr Roberts ascended to 3,500 meters, the highest continuously settled elevation in the United States, to install the Western Hemisphere's first Lyot coronagraph at Climax, Colorado. The observatory was a small wooden hut. The land itself was leased from the Climax Molybdenum Company, then the world's largest producer of molybdenum, a metal essential to armor plating, aircraft engines, and the high-strength steels of wartime production. The Lyot coronagraph was invented by the French astronomer Bernard Lyot at the Pic du Midi in 1930. Its principle was elegant. A metal occulting disk blocked the sun's radiating body, produced an artificial eclipse, and rendered the corona visible. But the instrument was extraordinarily fragile in epistemic terms. A single dust particle on the occulting disk would produce diffraction artifacts indistinguishable from the corona itself. What counted as a valid observation depended at every moment on what the building was doing to filter the world outside. The elevation itself minimized atmospheric turbulence. The orientation tracked seasonal solar trajectories. The material configuration, timber walls, the dome's drive mechanism, the thermal mass of the hut, controlled the temperature gradients that would otherwise corrupt the image. Architecture and instrument, one could argue, were inseparable, and this is what separates Climax from the long tradition of observatories that merely house their telescopes. The building's material performance was the observation. The operative disconnectivity at Climax was atmospheric. Roberts withdrew from the lower atmosphere, its dust, turbulence, thermal instability, to attend to a phenomenon invisible from sea level. Altitude was the building's precondition, not its setting. The same altitude placed the observatory in particular company. As Hannah Rose Shell has shown, the Climax had occupied a liminal position between the industrial and the celestial. Extraction and abstraction operating on the same mountain. The Climax Molybdenum Company had cleared the ridge for the removal of strategic ore from beneath the surface. Roberts arrived to install another form of planetary tension above it. 2 architectures pointed in opposite directions, one descending into the rock, one calibrated to the sun. The mountain was the shared infrastructure. From this small wooden hut grew an institutional architecture of considerable scale. The high-altitude observatory expanded under Roberts' direction, becoming in 1960 one of the founding components of the National Center for Atmospheric Research, for which Roberts commissioned IMPA to design the Mesa Laboratory in Boulder, which Stuart Leslie has written about beautifully. But the case I have dwelled on longest is also the simplest. The climax hut is where the argument of this paper becomes visible in its clearest form. A small structure whose modesty is inseparable from its capacity to render an alien phenomenon perceptible. Ascending was the first move and the most legible. The two that follow, descending and extending, push the same logic into stranger territory. Climax ascends to disconnect from atmospheric interference. The next case inverts its logic. Located 1,000 meters beneath Mount Ikeno in Japan's Hida region, Super Kamiokande is an architecture that descends into the earth, seeking not light but its radical absence, withdrawing from the surface to attend to matter that barely interacts with the ordinary world. Super Kamiokande was built between 1999 and 1995 by an international collaboration led by the Institute for Cosmic Ray Research at the University of Tokyo under the physicist Yoji Totsuka. It succeeded the earlier Kamiokande detector, which in 1987 had observed neutrinos from a supernova in the Large Magellanic Cloud, a discovery that earned a share of the 2002 Nobel Prize and effectively founded neutrino astronomy. The site was chosen for its rock and its infrastructure in equal measure. The Kamioka mine, one of Japan's longest worked mines, in operation from the 16th century until 2001, provided existent shafts and access tunnels at a kilometer's depth. As at climax, an extractive site became a scientific one. The same mountain whose interior had been emptied for ore was reopened for cosmic detection. The operative disconnectivity at Kamioka is geological. 1,000 meters of rock absorbed the cosmic ray bombardment that would overwhelm the detector on the surface. The mountain is not merely the site, but a geological participant in the apparatus. Its hill gneiss, a Precambrian metamorphic rock, provides a seismic and radiative silence no surface architecture could reproduce. Where climax withdrew from the lower atmosphere, Super K withdraws into the lithosphere. The shared logic, withdrawal as precondition for attention, produces inverted architectures. What matters for architectural history, I want to argue, is the completeness of the collapse between building and instrument. The cylindrical tank, 40 meters tall, lined with 11,000 photomultiplier tubes, does not house a detector, it is one. Every element is calibrated to its detection function. The 50 centimeter photomultipliers were custom developed by Hamamatsu Photonics. No off-the-shelf detector existed at that scale. The inner surface is lined with black polyurethane resin to absorb stray photons. The water is continuously recirculated through a purification system, processing roughly 60 tons per hour. The architecture computes. The spatial arrangement of photomultipliers translates the subatomic event into a legible signal. This collapse was revealed brutally and expensively on the 12th of November 2001. During a refilling procedure, a single mode photomultiplier tube imploded near the bottom of the tank. The shock wave cracked the neighbors within seconds. Roughly 6,600 of the 11,000 photomultipliers had been destroyed in a chain reaction. The event demonstrated, in the most literal possible form, the identity between architecture and instrument. When the material fabric failed, the epistemic capacity failed simultaneously. The detector did not stop working because its experiment had ended. It stopped working because its building had broken. Super K was rebuilt over 5 years, each photomultiplier now enclosed in a fiber-reinforced acrylic casing, an evolutionary logic in which each generation responds to the failures of the previous. What was built once at Kamioke has become a site of architectural accumulation. The same mountain now houses Kagra, a cryogenic gravitational wave telescope, the world's first underground interferometer of its kind, and the under construction Haipak Kamiokande, whose 69-meter diameter cavern will be one of the largest human-made underground spaces ever built. The Kamioka mountain has become a campus of withdrawals, a form yet to be named. The next case study in the Tuscan Plain shows what happens when withdrawal can no longer go down and has to extend instead. The European Gravitational Observatory takes operative disconnectivity to its most extreme expression. Where climax ascended and Super K descended, Virgo extends laterally across the Tuscan plain, just kilometers from where we sit today. Its two perpendicular arms, each 3 kilometers long, detect gravitational waves, ripples in space-time produced by astrophysical cataclysms such as black hole mergers and neutron stars in spirals. The signals it registers travel for billions of years before arriving here, and when they do, they shift the length of Virgo's arms by 1/1000th of a diameter of a proton. Virgo was conceived in the late 1980s by the Italian physicist Adalberto Giazzotto of ENFN in Pisa and the French physicist Alain Brillet of CNRS in Orsay. Its central innovation was Giazzotto's superattenuator, a suspension system that isolates the mirrors from low-frequency seismic noise. Construction at Cascina began in 1996. The detector first operated in 2007, and after the advanced Virgo upgrade, re-entered observation August 2017, contributing within 2 weeks to the first multi-messenger detection of a binary neutron star merger. Unlike Super K, the Cascina site was chosen for institutional rather than geological reasons. The alluvial Tuscan plain is, on its face, a terrible site for an instrument discriminating displacements smaller than a photon's diameter. The building was sited where the institutions were, and the architecture then had to compensate for the choice. The operative disconnectivity at Virgo is vibratory. The instrument's task is to register vibrations from collisions billions of light years away while suppressing every terrestrial vibration that is not a signal from deep space. The tremor of a passing truck, the thermal contraction of a mirror mount, the gravitational tug of passing clouds. Where Climax withdrew from the lower atmosphere and Super K into the lithosphere, Virgo withdraws from a frequency band. It does not displace itself in physical space, it discriminates within a spectrum. Every material decision at Virgo is simultaneously structural and epistemic. Vacuum pipe diameter, mirror suspension pendula, foundation isolation. Giazzotto's superattenuators suspend each test mass through chains of mechanical filters some 8 meters in height. The vacuum tube system is the second largest ultra-high vacuum installation in the world after CERN's Large Hadron Collider. The building does not house the instrument. The building is the instrument. An architecture of non-human attention, attuned to the disturbances billions of years old, registered as displacements smaller than any human technology has ever measured. The audience the building was designed to address is, in the most literal sense, the cosmos. For architectural historians, Virgo poses a limit question. This building belongs to no established typology. It is not really a laboratory, it has no interior workspace for bench experiments, it is not an infrastructure in Keller Easterling sense, it does not organize flows across territory. It is closer to what Shannon Mattern, Jesse Parica, and Jennifer Gabris have variously called other urban intelligences, geological media, and computational planets. Virgo and Kagra are architectures that think through vibration, operating by disconnecting from terrestrial disturbances in order to attend to cosmic ones. Harry Collins's sociology of the gravitational wave community has traced the decades of negotiation required to distinguish genuine signals from instrumental artifacts. That problem at root is architectural. How to build an environment in which a vibration from two merging black holes 1.3 billion years ago can be separated from a vibration of ocean waves striking a distant coastline. What follows Virgo is already under design. The Einstein telescope, a triangular tunnel system with 10-kilometer edges, planned for either Sardinia's decommissioned Sosenatos mine or the Meuse-Rhine Euro-region, will bury the interferometer beneath the Earth. The architecture combines the subterranean disconnectivity of Supercomioconde with the vibratory discrimination of Virgo, a single building that both descends and extends. The source in Athos candidacy is worth noting. The site is an exhausted 19th century lead and zinc mine decommissioned in 1997, whose galleries register one of the lowest seismic backgrounds in continental Europe. A third decommissioned mining site, after Clemens and Komioka, would become a planetary observatory. The trajectory from climax to Cascina describes the progressive enlistment of architecture in encounters with materialities radically other to human experience. The corona graph attended to the solar corona by ascending, Super Comieconde attends to neutrinos by descending, Virgo attends to gravitational waves by suppressing every terrestrial vibration that is not a single from deep space. In each case, the building must become strange, elevated, buried, evacuated, hyper-purified, to tend to forces human perception cannot access unaided. These are architectures of non-human intelligence, not because they think, but because they tend. The cumulative claim is this: the architectures of contemporary planetary science are not only tools for knowing the planet. They are part of what makes the planet knowable in the first place. The corona, the neutrino, and the gravitational wave exist independently of any architecture. But for them to enter human scientific cognition, a building must exist that can filter them out from everything else. What the planet is, as an object of knowledge, is conditioned by what architecture has been built to attend to. One pattern is worth naming before I close. Climax was leased from a molybdenum company. Super Comieconde reuses the shafts of a zinc and lead mine. The Einstein telescope, if built at Sos Enatos, will occupy a decommissioned lead mine. Virgo is the productive exception. The mind-to-observatory genealogy is a recurrent pattern, though, not a universal one. Operative disconnectivity, as I've outlined it then, is not a typology per se. It is the name I propose for what these buildings do. A calibrated operation of withdrawal and connection that conditions what the planet, the cosmos, and the alien in turn can be known as. If architectural history accepts the invitation to think about these buildings, what is at stake is the recognition that the history of planetary science has, all along, been an architectural history, and one we have barely begun to write as such, a planetary history of architecture. I borrowed the title Alien Earth from my exploratory talk today because the Alien franchise stages with unusual clarity the problem this paper addresses: how architecture confronts matter that exceeds it. The buildings I have described today are an answer. They do not collapse before the alien, they withdraw, they filter, they attend. But every act of architectural attention is also an act of architectural inattention. The planet that becomes knowable through these architectures is a planet that's shaped by what we have decided to listen for and by what we have decided to overlook. Each observatory is also an act of selection. Every act of selection is also an act of erasure. And yet what these architectures have been calibrated to attend is worth naming. The corona is the outer atmosphere of the star that makes terrestrial life possible. The neutrino is a witness to the nuclear processes that forge the elements of which all matter is made. The gravitational wave registered the deaths and collisions of stars in which heavy elements, gold, iron, carbon, were produced in the first place. The corona, the neutrino, and the gravitational waves are not exotic curiosities. They are, in different registers, the building blocks of the universe, our planet and us. Which means that the architectures of operative disconnectivity are not only architectures of planetary knowledge, they are also the architectures through which we have begun to encounter our own constituents. To write the architectural history of these buildings is to write a history of how the discipline has been participating all along in a project larger than itself, the project of understanding our place in the universe, our planetary condition. Thank you very much.
So, thank you. Now we go on with Professor Josep Maria Garcia Fuentes of Politecnico di Milano. The title of the presentation is Visionary New York, a Proactive Manifesto for Manhattan.
Well, thank you. Good afternoon, or almost good evening, everyone. So thank you very much, Lina and all the team, for organizing this conference or seminar. And thank you, everyone, for the courage to listen at this time after lunch, which I know it's a critical time for everyone, also for myself. So in 1976, Roger Ferry designed a pioneering skyscraper. The project was intended as the headquarters for a corporate entity and built to the maximum volume permitted by zoning laws to maximize profit, following the well-known design principles of New York's capitalist towers. Its radical concept, though, consisted of integrating an indigenous landscape into its terrace and step massing, creating a continuous park accessible from street level and throughout the building. The park features native flora and fauna with lakes, rocky areas, hiking trails, prairies, lawns, cliffs, and waterfalls throughout, culminating at the top of the tower, where a viewing plateau and a mountain museum were planned. This is a living ecosystem, engineered scientifically and architecturally accessible to all, integrated into the skyscraper to function as part of a larger interconnected building ecosystem, which in turn connects to other broader ecosystems. Ferry graduated in architecture from the Pratt Institute only 4 years before this design, in 1972, at the age of 23. He was born and raised in New York, the second generation of a family of Italian immigrants, originally from the Milan area. During the years in which Roger studied there at the Pratt Institute, the institution was marked by an intense climate of student and faculty activism, tackling a range of issues from curriculum problems to civil rights issues, being precisely the years from 1968 to 1972 the most intense. This is precisely the years when Roger was a student there. The architectural debate back in those years at Pratt, and more widely in the New York area, was shaped by modernist and post-war American architecture and by the emerging ecological and system thinking, which was strongly linked to the New York professional practice. This ecological concern was fueled in the early 1970s by the oil crisis and the emergence of a wider environmental movement, which helped develop and strengthen ecological thinking in the natural sciences and beyond. The publication of Rachel Carson's famous Silent Spring book in 1962 marked the emergence and exponential growth of the environmental movement in the wider public. As the book documented, the environmental harm caused by the indiscriminate use of DDT, a pesticide used by soldiers during the Second World War. Carson accused the chemical industry of spreading disinformation and the public administration of accepting the industry's marketing claims unquestioningly. The intense public debate sparked by the book, along with other events such as the 1969 oil spill in Santa Barbara, laid the ground for the celebration of the first Earth Day on April 22, 1970. This is precisely while Roger was still an architecture student at Pratt. The influential and mainstream publication of Design with Nature in 1969 by Ian McCarr quickly became a major force at the Pratt Institute during the years in which Ferry studied there, through academic and teaching staff like Stuart Dawson, directly connected with McCart's pioneering program at Penn, George Raymond, or John Tillman Lyle. McCart's basic idea was that we should use ecological knowledge to guide design and planning. His ideas were grounded in those of Patrick Geddes and bridged knowledge across disciplines, primarily science and design, with a revolutionary focus on planning and landscape architecture. He actually became a very famous TV star, as you can see it in these images. And in the book, in Design with Nature, McCarr explicitly elaborates on the work and ideas of scientists such Charles Darwin, Odum, both of Odum, Eugene Odum and Howard Odum, and as well Rachel Carson. McCarr founded the landscape architecture department at Penn after graduating from Harvard University and became a pioneer in connecting design to ecological sciences. Numerous studies have focused on his key role in shaping contemporary landscape architecture and planning, as his ideas and pioneering practice laid the ground for the emergence of GIS technology, which probably you are familiar with it, about mapping. Actually, if we look at, if we flip through the pages of Design with Nature, we see all these diagrams with all these arrows trying to map ecological processes and how the transformation of ecosystems happens. Because of course that analysis and that diagram of ecological process is essential in order to be able to design with them and to work with them. Indeed, it's interesting because, however, little attention has been paid to the way that Macquart's ideas quickly spread into architecture, as for example, into the works of Louis Kahn. Actually, the works of Louis Kahn reveal that, because both Macquart and Kahn were colleagues at Penn. They were actually sharing offices in the same corridor and worked together on some professional projects, like, for example, in their famous plan for Philadelphia, the one that you see here in the image, by the way, with a lot of arrows trying to map sort of artificial ecosystem, which would be the traffic, and for which Kahn, as probably you know, designed these famous parking towers as the new modern city walls of the city. Both Macquart and Kahn were close friends as well, and they were often exchanging ideas in informal contexts, like at baseball matches, for example, which is a very important moment for social and intellectual exchange. The influence of Macquart's thinking on the work of Kahn and other contemporary architects, such as Ferry, has remained largely unexplored to this day. Roger was or is certainly aware of Macquart's Design with Nature, and its influence becomes clear in his visionary skyscraper design for Madison Square. Note, for example, his precision in including native flora and fauna in the building's park. It is not a casual remark on a narrative claim, but a conscious design choice informed by a specific scientific knowledge. The architect thus mobilizes science to craft a unique design and a visionary project. Ferry's project, colleges, shed further light on this connection, the ones that you see now in the screen, as he uses postcards from nearby parks to produce these images of the project. And he writes in small text about the project that the park consists of transplanting a native landscape intact with its flora and fauna to the Manhattan skyline. Materials, living plants, fauna, and even rocks are transplanted to create an ecosystem entangled within the city and other regional ecosystems. The setbacks receive a mountainscape excavated from living rock upriver from New York City that are upheld in deep concrete basins arranged in a diagonally ascending manner, reassembling the mountain fragments of the original site. It is not just a transplant, but a newly crafted ecosystem formed by grafting other fragmentary components from nearby ecosystems. The goal is to create a truly ecological and scientifically grounded design. But Ferry explores Macquart's ideas further, beyond planning and landscape design, as he develops his vision for the building design. The role of the ecological transplant in the skyscraper is multiple, spanning from the city scale and the city design, and this is therefore a dimension that is well connected to Macquart, down to the specifics of the building interior spaces. And Ferry is concerned with both the citizens and the building's users' well-being. And for these reasons, he plans the park to be accessible at all points throughout the building, even from street level, and to remain accessible to the public continuously to its top. Ferry envisages that at each intermediate floor, workspaces overlook a constantly changing tableau of wilderness and dense metropolis with direct outdoor access for staff. The goal is to experience a constantly shifting collage of densest metropolitan structures amidst sylvan foreground. This strong concern with offering a well-balanced setting between a dense urban technological environment and a constant view and experience of a wild environment seems to come straight from Richard Neutra's projects, thoughtful writings and conferences that connect quite explicitly science, design, and dwelling. Neutra published his famous, though I would say very unread book by architects, Survival Through Design, in 1954. The book has no illustrations, absolutely not even a single one. So maybe that's the reason why architects usually don't read the book by Neutra, because we all know that we love books with images, and when there are no images, those books are not so appealing for architects. And then the book is actually very lengthy. It has a lot of pages, and it's organized as a collection of 47 short chapters through which Neutra develops his thesis, summarized in each chapter's title. The text is written with a complex combination of numerous philosophical, scientific, and artistic references, demonstrating Neutra's deep awareness of the essential contributions of these disciplines, as well as the latest scientific developments and the most innovative contemporary scientific and technical research and discoveries. Referenced scientists include Walter Cannon, Ivan Pavlov, Kurt Lewin for psychology, Charles Darwin, and Alice Carroll for natural sciences and biology, or Norbert Wiener for mathematics, just to mention a few, because it's full of constant references. Neutra is particularly concerned by the problematic relationships between human beings and the environment caused by the exponential acceleration of industry and modern technological development, which have also led to unreasonable changes in modern lifestyles. Most of these ideas are exploring Neutra's architecture, particularly in design strategies that bridge this gap between the modern technological environment and the wildness that has been key to shaping human senses and biological and psychological adaptations throughout the millennia. Ferry's concerns in his pioneering design to provide a constant and well-balanced experience between modern technological spaces and an ideal wild Arcadia, ecologically designed, connect directly with Neutra's anxieties and designs. And actually, in the skyscraper project itself, Roger writes that the design could merge the utopian and the Arcadian images into a personal vision of Paradise Garden, the world in balance. Being the utopian, the Midtown skyline, a man-made fantasia with its steel sunbirds, polychrome obelisk, and skybound temples, and the Arcadian, the elemental expression of nature. In the conceptual and material dimensions of this balance, Neutra's last book, completed just before he passed away and published 1 year after his death in 1971, resonates, which is this building with nature. The attention to science shown by McCart, Neutra, and Ferry is evident in their integration of system thinking into the design process, drawing on scientific knowledge, particularly in biology, psychology, and ecology. Although Ferry doesn't include any direct references to sciences in his very few writings, but rather to scientific reports, it is worth underlining the differences that both McCart and Neutra make to a wider debate sparkled by the opposition of Charles Darwin and Lawrence Anderson, as their discussion resonates at the core of the topic here. Both McCart and Neutra oppose the well-known idea advanced by Darwin that the organism that survives is the most suited to the environment, and Lawrence Henderson's idea that the actual environment constitutes the fittest possible adobe for form of life that has existed, does now exist, and all imaginable forms that can exist. Therefore, survival is not only the consequence of an organism adaptation to the environment, but in fact, a complex process in which both the organism and the environment mutually shape each other. And I think this is quite an important idea to understand this concept of design with nature. The in-depth understanding of this idea actually marked a turning point in modernity with specific consequences for architectural design. As it reminded architects of architecture's original goal, which is to design and build with nature to allow human survival. Ferry kept his attention to science throughout his life, and actually, in the longest and most articulated of his very few texts published in 1987, he writes that since the relationship of the built world to the natural order is at the apex of the architectural hierarchy, any serious evolution of architectural values must begin here. The primary concern of architects today should be to help develop such a physical model for the reintegration of the man-made environment and nature into a functioning symbiosis. The need for the reintegration of architecture and nature became always more important to Ferry since the late 1960s. Because, as he writes, the magnitude of our technological progress has reached the scale that, for the first time in history, we can alter irrevocably the balance of nature itself. According to Ferry, our actions continue to be guided largely by an adversarial attitude towards the natural environment, which grew out of the age-old struggle to domesticate overwhelming natural forces. And as a result, our actions now threaten the stability of nature itself. These words demonstrate Ferry's careful attention to the contemporary scientific debate on the environment. His reflections, however, extend beyond this point, as he further elaborates on the relationship between climate change and the utilization of natural resources. For him, the most bitter and the most frightening outcome is the greenhouse effect, the global warming of the Earth's atmosphere that's already underway. And he even specifies that its primary causes are the combustion of fossil fuels, deforestation, and present land use patterns. Its most devastating consequences include rising sea levels from the polar ice mass, the melting of the polar ice mass, which will threaten coastal lands and cities within our lifetime. Major agricultural destruction caused by climate change and expanding desertification in the northern hemisphere, including the United States. Even more ominous consequences are thought possible. And this is something that Ferry was writing back in the 1980s, so many years before today. Ferry's approach to science, therefore, seeks to reintegrate knowledge into architecture with scientific precision. This can be observed both in design, as exemplified by his skyscraper project, and at the critical level, as he recognizes that the notion of nature traditionally embraced by modern architects was understanding nature as a warehouse of resources to be exploited. And that's a notion that by the time of Ferry had already been surpassed by the new scientific understanding of nature as ecology. As Ferry himself states, the indiscriminate abuse of Earth as a mode of industrial policy, so aptly characterized by Louis Mumford and the mining mentality, found its equivalent in such modernist development models as Gropius Hasselhoff's proposal of 1929 or Le Corbusier's Poisson plan for Paris, in which the space of nature has been reduced simply to land as a uniform, hierarchically indifferentiated resource to be exploited like coal. The consequences of this abuse go beyond the ecological realm, because as Ferry states, by doing so, our spiritual life is destroyed as thoroughly as our physical life. And we can observe that the tragedy of a polluted stream lies in our diminished sense of wonder. And that's interesting because it acknowledges also this connection between Ferry, Kahn, and Makar, as I was pointing at before. It is precisely at the time when Ferry designs his visionary skyscraper that the modern vision of nature as a warehouse of resources has collapsed alongside with modern architectural projects, and they are being overcome by a more complex ecological understanding related to this system thinking. The emergence of environmental movement, the works of Makar and Neutra and Kahn and Ferry, or the publication of The Limits to Grow by the Club of Rome in 1972, making the case for a systematic transformation of humankind's relation to the earth, clearly point towards the emergence of nature's ecological understanding. The consequences for architecture and the potential to mobilize scientific findings in architectural design are colossal in this sense. And Ferry's skyscraper design demonstrates that. In his text, actually, he uses the word reintegration, which I think is revealing. The title of the text that I just mentioned is precisely Architecture of Reintegration, an essay in 3 parts. And the text develops the idea that architecture, the man-made environment, and nature must be reintegrated into a functioning symbiosis, embracing ecology and well-being. He structures the text in 3 parts, discussing the environmental challenge and the failure of modern architects to address this original goal of architecture, his proposal for a pedestrian city, and an architecture as the way to reconnect urban and architecture into the ecosystem, and a reflection on representation as the key tool to turn reintegration into something real and to move away from abstraction and narrative ideas. Drawing is visual thinking, as Ferry himself would synthesize. Ferry's concept of reintegration recalls Henry Russell Hitchcock, Modern Architecture, Romanticism and Reintegration, and more notably, Geoffrey Scott's The Architecture of Humanism from 1914, when it focuses precisely on the reintegration of architecture and nature. Ferry's fondness for Scott's book and ideas is well known, and it's very well documented. And we could point specifically to Scott's biological fallacy in relation to Ferry's criticism of modern architecture and to his explorations to reintegrating man-made and natural environments back in symbiosis through the mobilization of scientific knowledge within architectural design. The work of other contemporary scientists, artists and architects like Giorgi Kepes or the Italian Superstudio resonates in Ferry design, and we could discuss further on that. But his groundbreaking project for Manhattan anticipates ecological thinking and design for several decades in a very unique way. In this sense, it is probably the omission of Ferry's skyscraper in Rem Koolhaas' seminal book, The Lyrics New York, that's revealing of the project's historiographical fortune. By the time that Koolhaas' book was published in 1978, including built and unbuilt designs from 1850s to the 1960s, Ferry's radical design had already circulated, and he was even featured on the cover of Damus magazine in 1977. Though it was probably little understood, because even almost 10 years later, in 1986, the magazine Eupalinos published a selection of Ferry's projects, together with an article, a very short text by Paolo Portoghesi. The skyscraper was not included among the future designs published in Eupalinus, and was not even mentioned in Portuguese's text, which insisted on Ferry's pedestrian city project, and insisted also or discussed on the uniqueness of his ideas that connect both European and American traditions, and on Ferry's connection to franchise rights inheritance, which would be something a bit more predictable probably. And was also commenting on the difficulty of approaching such a rich and talented architect as Roger Ferry was. Nevertheless, Roger Ferry's visionary project already marked a pioneering turning point in a skyscraper design, far ahead of Koolhaas thinking, and even of the current project exploring ecological tower buildings, like, for example, this clumsy project by Jarke Ingels, which seems like a very rude or very rudimentary interpretation of all the richness of Ferry's ideas. In this way, Ferry's project stands still today as a visionary design and a scientific manifesto for survival. So thank you very much.
So the next talk is by Anna Ranken from University of Toronto. The title is Dynamic Construction, Ecosystem Concept in Architecture After the 1960s.
Thank you. And I just wanted to start by saying thank you so much to Lena and all the organizers and to everyone for being here. All right. I also just wanted to say this is part of my ongoing dissertation research and something I'm kind of thinking through in terms of how I'm framing my case studies. Yeah. All right, so I will get started. Okay, and this paper is called Dynamic Construction, Ecosystem Concepts in Architecture After the 1960s. So the concept of the open system played a key role in environmentally motivated work led by a variety of designers in the 1970s and subsequent decades. Many familiar design approaches, like the ones shown here, have positioned buildings and communities as closed systems, whether sealed off physically to protect from volatile surroundings or conceived as self-sufficient in terms of energy and resources. And this is something that has been discussed by scholars such as Lydia Calippoli and Peter Anker. In contrast, design work more aligned with open systems has foregrounded interaction between the built and natural environments. Unfolding in a period of increasing and shifting environmental concern over issues from pollution and the oil crisis to global warming, this work situated humans as fundamentally part of dynamic environments, more than imagining an ideal nature in need of protection or restoration. Through a close examination of publications and archival materials, this paper considers how design educators Ralph Knowles and Wolf Hilberts drew from systems thinking, cybernetics, and ecology as they worked to understand and intervene in changing environments. By investigating and comparing these two cases, I will suggest that engagement with ecosystem concepts emphasizing change and uncertainty guided their development of novel design techniques. And I see these case studies as representative of a strand of ecological design work that developed through dialogue with science and technology in the late 20th century in the United States. Following well-known efforts of the 1960s, including some of those that were shown in the previous presentation, such as those of Ian McHarg, as well as Victor and Aladar Olge, a variety of design educators and practitioners worked to integrate design more deeply into environmental dynamics, in part by adopting ideas and methods from the natural and applied sciences. Among these, Ralph Knowles led the Natural Forces Laboratory at the University of Southern California, and Wolf Hilberts directed the Symbiotic Processes Laboratory at the University of Texas at Austin. These are shown on the screen here. Moving between the laboratory and the field, these groups worked to intervene in established design and construction practices. In key long-term projects, Knowles piloted an alternative planning process and Hilberts invented novel fabrication techniques, while each developed knowledge of ecosystems from urbanizing arid valleys to industrializing subtropical coasts. Building on previous studies of work by Knowles and Hilberts by scholars including Albert Nareth and Larry Busby, I seek to track how ecology and systems thinking influenced their conceptual and material practices. So I'll start with Ralph Knowles. The work that Knowles led at the Natural Forces Laboratory was premised on an understanding of the environment as a system of natural forces, the sun, wind, and water, that were in continuous interaction with the earth and built form. Knowles investigated the dynamics of the sun, while his colleagues in architecture and landscape, Pierre Koenig and Emmett Wemple, focused on wind and water. Each of these professors worked with students to develop laboratory instruments to simulate the force that they focused on, as shown here. So there's a heliodon on the left, a wind tunnel in the center, and an experiment using water to study erosion on the right. Breaking the environment down into these forces enabled the group to study their interactions with form in the laboratory and the field, moving toward an understanding of complex systems in which these forces were combined. Throughout this work, Knowles used the concept of the open system to describe natural environments and to guide the design of buildings and communities within them. He and his colleagues introduced the idea of the open system in teaching materials from the late 1960s. An undergraduate studio outline, for example, states that, quote, natural systems constantly exchange materials, energies, or information with their environments in a way that is favorable to their continued operation, end quote. These open systems, the text elaborates, stand in contrast to closed systems that are, quote, considered to be isolated from their environments in the manner of conventional physical models. This course outline, along with other archival records, cites works by key systems thinkers like Ludwig von Bertalanffy, which in turn referred to others, including that of the chemist Ilya Prigogine. Von Bertalanffy described how an open system, like a living organism, quote, maintains itself in continuous inflow and outflow, a building up and breaking down of components, which constituted what he called a steady state. This idea challenged principles of conventional physics that were based on closed systems, including the second law of thermodynamics, describing how entropy in a system increases over time, tending toward disorder or randomness. Instead, open systems can, quote, develop towards states of increased order and organization, as in the examples of organisms and evolution. Drawing on these ideas, Knowles and his colleagues saw nature in terms of open systems. Knowles also brought this concept of the open system into architecture, arguing that buildings should be designed in relation to their dynamic environments. In a 1968 lecture, he notes that, quote, we tend to think of the building as an isolated thing, as a closed system, capable of providing some fairly consistent internal condition that is independent of what is outside, end quote. By challenging this notion and focusing instead on how the environment affects architecture, Knowles suggested that, quote, the building might then respond directly and begin to exhibit some of the attributes of natural systems. So here, Knowles situates open systems in nature as models for design. Oh, sorry. And this approach can be seen particularly clearly in the laboratories, the Natural Forces Laboratory's work with sand dunes, which take on form through interaction with wind. As shown here, the group studied dunes through their fieldwork and laboratory simulations, and they produced related models as possible designs for megastructures that would emulate their qualities. At a larger scale, Knowles engaged with ecosystem concepts while devising strategies for the planning of communities. In his 1974 book, Energy and Form, An Ecological Approach to Urban Form, Knowles referred to the work of the biologist Eugene Odum, a key contributor to the concept of the ecosystem. Knowles quotes Odum's discussion of the phenomenon of succession as, quote, an orderly form of community development that ultimately leads, quote, a stabilized ecosystem in which maximum biomass or high information content and symbiotic function between organisms are maintained per unit of available energy flow. In developing a planning framework for the Owens Valley, a region north of Los Angeles, Knowles suggested that similar patterns of energy exchange and increasing organization might be produced in human communities. He goes on to specify how notions of variety and diversity in biology might inform what he called analogous phenomena in buildings in support of a form of stability. In the planning framework, he divided the region of Owens Valley into distinct domains based on a measure of environmental change, as shown on the left. And he then developed rules for designing within these domains. And an example here is shown of buildings that could be developed within this grid based on the movement of the sun. As implied by these intricate sloping models built by students, this framework employed ecosystem analogies, but it also sought to integrate design physically into the region's ongoing ecological dynamics. Striving to develop open systems in interaction with the natural environment, Knowles and his collaborators developed design tools that allowed for uncertainty, both about the environment and in the design. Their overall method of focusing on individual natural forces offered one way to do this. For example, in his work on the force of the sun, Knowles introduced a device that he called the solar envelope, which specified spatial relationships in order to maintain access to the sun's light and energy within densifying urban areas. This relational approach did not assume an understanding of precise relationships within ecosystems or dictate the exact form of design, but rather responded to change in both the natural environment and the form of the city. Writing in the 1990s, amid rising ecological concerns, Knowles described the work on natural forces at USC as a way to provide, quote, an underlying order in an increasingly chaotic and unpredictable built and natural environment. So from this group's sand dune studies to their development of planning tools, the laboratory's activities imply an understanding of humans as part of the changing environment, with the potential to shift their actions in support of its larger dynamics. So then I'll turn to the case of Wolf Hilberts and the Symbiotic Processes Laboratory. Hilberts oriented his work with the Symbiotic Processes Laboratory toward the design of systems that could produce evolving environments and support existing ecologies. Along with colleagues in architecture and engineering, he led students in experiments with organic and inorganic materials, from plant matter and water to plastics and metals, using an array of tools and machines, as shown in the images here. This work sought to develop alternative approaches to building based on material processes such as accretion, as in the formation of caves and coral reefs. Combining laboratory experiments with fieldwork, this group learned about environments while actively intervening them in an ongoing and iterative process. Ideas from cybernetics and ecology, such as feedback and symbiosis, were crucial to the framing of their work, as they studied and interacted with a variety of organisms and environments. Bringing ideas from cybernetics into architecture, Hilberts introduced his concept of cybertecture in 1970. In this manifesto-like text towards cybertecture, he states that, quote, the space-time continuum is organized ecosystematically as it relates to a complex of ecological community and environment, forming a functioning whole in nature. Finding architecture to be piecemeal and chaotic in comparison, Hilberts presents cybertecture as a way to realign design with the environment. Cybertecture, he explains, quote, is structured and performs in a manner analogous to open living systems. Cybertecture would consist of 3 subsystems, including a computer or brain, a material distribution and reclamation system or metabolism, and a sensing structure or body. Hilberts' use of the phrase open living systems reflects the influence of work by Prigogine, von Bertalanffy, and others to describe organisms and evolution. Illustrated with a bubble diagram shown on the right, which is itself characteristic of systems thinking, cybertecture also incorporated key cybernetics concepts like feedback, as the 3 subsystems that Hilberts defined would work together to sense the environment and alter the structure in response. The early work of the Symbiotic Processes Laboratory suggests an effort to almost directly materialize this diagram of cybertexture. Discussing natural precedents like spider webs and bird bones, Hilbert's 1970 article stated that cybertexture could, quote, be initiated in any kind of environment, above or under Earth, underwater, or in outer space. Participants in the laboratory pursued these directions through a range of studies and experiments in the lab and the field. For example, they used lasers to harden polymers and sprayed water over wire armatures to form ice, as shown here, testing these processes as potential adaptable building techniques. Hilbert's employed terms common in systems thinking, like self-organizing, to describe the structures they produced, in an apparent effort to initiate systems that could then develop beyond human control. Further, the group often presented these experiments as proof of concept for larger visions, such as underwater complexes like the one shown here, that would bring humans into contact with other entities. As the group's work continued, they began to explore models for interaction between humans and non-humans, placing greater emphasis on ecological ideas such as symbiosis. In a 1972 text called Strategies for Evolutionary Environments, Hilbert's referred to a range of scientific and philosophical work on how environments and organisms influence each other, including human impacts on evolution. Rather than continuing anthropocentric patterns that increase entropy in the environment, he asserts that humans should, quote, develop systems which can continually transform living and non-living matter into ever higher levels of organizations. So, in other words, systems to support humans and other entities as interconnected. In this spirit, Hilberts and his collaborators explored an unconventional fabrication process that he would go on to patent, and that he called mineral accretion, or using electricity to induce the deposition of minerals from seawater onto metal armatures. The formation of coral reefs served as a model for this work, and was also physically integrated into it. Here, Hilberts introduced an experimental technique that he called phasing, alternating in experiments between periods of electricity-induced accretion and the activity of marine life without it. This iterative approach might be seen as incorporating feedback into a building process, as in the concept of cybertexture. Through these experiments, Hilberts and his collaborators envisioned the development of larger communities that they understood would develop through a form of symbiosis, as accretion would produce architecture for humans while offering food and shelter for marine organisms. And an example of one of these visions is shown on the right. So as the Symbiotic Processes Laboratory worked within complex ecosystems, they developed strategies for engaging non-human entities while actively learning about them, managing uncertainty about the process that they were testing and the larger environment. The group's earlier work on fabrication and adaptation, stemming from the concept of cybertexture, did not always attend to the particulars of the materials or contexts involved. Yet as their work developed over a period of increasing awareness of climate change, they identified a crucial and threatened ecosystem, the coral reef, as the site for their intervention. In their experiments, they devised mechanisms like phasing to observe how ocean ecosystems interacted with the structures that they initiated, and they adjusted their own contributions in response. You can see this in the images on the left that show how corals and algae grew on the structures and how humans monitored and interacted with them. This experiment-based approach, more broadly, allowed them to test different ways of interacting with non-humans. So Knowles and Hilberts both developed distinctive approaches through their laboratory-based environmental work, involving different concepts, sites, actors, and interventions into design. Knowles sought to understand environments by breaking them down into separate natural forces and proposed frameworks to guide design and construction in relation to their dynamics. In contrast, Hilberts began with cybertexture as an abstract model for design based upon living systems, and then worked to develop ways of building that would support forms of symbiosis. At the same time, these practices were both deeply informed by shared references from systems thinking and ecology. Both worked with the concept of the open system Knowles by seeking to shape buildings through interaction with their surroundings, and Hilbert's by modeling design after living systems in constant exchange with their environments. Aspects of the open system, such as its tendency toward order, influenced Knowles's approach to the planning of communities and Hilbert's efforts to initiate self-organizing structures. Further ecological concepts, including diversity and symbiosis, also became central to their respective approaches. For Knowles and Hilbert's, the natural environment offered both models and contexts for design. They found inspiration in open systems in the natural world, studying processes such as the formation of sand dunes and coral reefs, and extrapolating principles and strategies from them. While they employed analogies to situate design in relation to environmental dynamics, both Knowles and Hilbert's also worked to integrate their design physically into those dynamics. This is clear in Knowles's efforts to produce design that operated like and materially supported ecologies by maintaining access to sunlight, and in Hilbert's phasing procedures that combined human-initiated mineral accretion with the ongoing activity of marine life. Further, as Knowles and Hilbert's began to work within particular dynamic environments, they each devised open-ended design techniques to navigate uncertainty about those environments. Knowles sought to maintain spatial relationships between built form and natural forces like the sun in evolving cities, while Hilbert's engaged with marine life to support coral reefs threatened by climate change. Understanding humans as actors within changing environments, both Knowles and Hilbert sought to shift their attention and agency toward larger ecological interactions. Importantly, they did so not by imagining complete alternatives, but by beginning to operate differently within existing ecological and social contexts. And there are clear tensions in their efforts to alter patterns of human activity in which they were enmeshed. I believe tracking such uses of systems thinking concepts can help to strengthen histories of environmental design with implications for work in the field today. Thank you.
So our last speaker, Ante Irano from GTA Institute, ETH Zurich, who will present a talk entitled Experiments Out of Thin Air, Angelo Mosso Attitudinal Laboratory. Please.
Thank you, Lina, and all the organizers. Such a wonderful pleasure to be here among this illustrious line of colleagues and friends. Many thanks for accommodating this extremely preliminary effort of mine. It has often been said that the notion of the weird went through its modern transformation thanks to Shakespeare, though through the so-called three weird sisters in Macbeth, which refers not originally to something strange or odd, but to the divine beings associated with fate or inescapable destiny, derived from the Nordic equivalent of the Greek Moirai or the Roman Parcae. According to the mythologies, these powerful goddesses control the human destiny by spinning the thread of life. So the etymology of weird has to do with turning and winding, as if to set fate in motion, which is to say that there was nothing weird about the weird until Shakespeare portrayed the three prophetic witches in Macbeth as spooky and frightening. This was before the word's spelling became stabilized. The first folio, for example, has it as wayward with an E, as if Shakespeare is playing with its spelling association with wayward with an A. And wayward with an A, if we recall, is one of Shakespeare's favorite words. And one of the ways Shakespeare makes the weird truly weird, in the sense of waywardness, has to do with some extreme weather conditions. The first scene of Macbeth is fully meteorological. Imbued in foul weather, the three witches entered in thunder and lightning, quote, "When shall we three meet again? In thunder, lightning, or in rain?" End quote. That's the first line of the whole play. And right after the famous fair is foul and foul is fair, quote, "Hover through the foggy and filthy air." In other words, inherent in the modernization of the idea of the weird lies a tension between destiny and caprice, between the intrinsically faithful and the extrinsically erratic, even meteoric, between the controlled interior and the mischievous exterior, as if fatality must come to pass in the most capricious form. Indeed, to be wayward is to deviate, right? To wander away, which relates to the question of where, as the first which asks pressingly, quote unquote, where the place? Okay, where the place? There's the rub. Here, Angelo Mosso, the 19th century Torino-based experimental physiologist, a follower of Carl Ludwig in Leipzig and Etienne Joumaret in Paris, an avid designer of scientific apparatuses who is extremely versed in the techniques of the graphic method with which to study everything from muscles to the brain, from blood circulation to breathing. In other words, someone already highly successful working within the laboratory of the city decides to go wayward. In 1885, the 39-year-old Mosso published a small book called A Winter Ascent of Monte Rosa, a narrative of his adventurous journey in the huge Monte Rosa massif of the Alps towards the border between Piedmont and Switzerland, apparently amid harsh snowstorms in February of that year. Before that point, Mosso has begun to conduct high-altitude research using the Alps as a natural laboratory to study human respiration. But unlike the strictly academic papers he published, for example, here in 1884, or a lot more soon to come, this book apparently belongs to a different register, quite unconventional to a physiologist, a wayward kind of literary form, if you will. Its very first sentence reads, quote, "Toward dawn, I felt that our carriage was passing over a bridge. My traveling companion, Alessandro Sella, lowered the carriage window, which was entirely clouded over with ice," end quote. So you get a sense of its literary quality, and in addition to some intensely freezing weather that already shows up here, which we will have more, we already notice his travel companion, Alessandro Sella, and if you are familiar with 19th century Italian alpinism, that family name already rings a bell. Alessandro is the eldest son of Quintino Sella, the famous Risorgimento politician whose lifelong passion is without doubt mountaineering. Indeed, Quintino Sella was the founder of the Club Alpino Italiano as much as a co-founder of Italy as a nation state, both born in the early 1860s in Torino. Risorgimento and alpinism are, in many regards, one project instead of two. Well, here, the physiologist and the alpinist went hand in hand into the terribly snowy, stormy Monte Rosa. And by hand in hand, I almost meant it literally, as Sella and Mosso with their mountain guides walked in severe cold and wind, blowing the dry, powdery mountain snow like desert sand, as Mosso describes it. They had to tie themselves together with a rope tightened around the waist to keep someone from falling into the treacherous crevasses of the glacier, which of course was nothing innovative. The rope as an alpinist technology has been a commonplace. But the problem of the rope is that if you fall together. Well, a point I will come back to. But why was Mosso here? Clearly, he writes in a manner that's more akin to the kind of alpinism literature that exploded at this moment among all the Alpine nation states, the German, the French, the Swiss, Austrian, plus the British, in these what Edward Whymper famously called scrambles amongst the Alps. Of course, infused with masculinity, militarism, nationalism, etc., etc. Literary scholars may call this genre a récit, that is the kind of dramatic monologue unfolding in prose. Mosso's account goes through all the meteorological ordeals, finally to the summit of the Vincennes Pyramid of 4,200 meters, culminating with the sublime emotions experienced on the summit. Quote, "More than any other earthly thing, the majesty of the Alps is capable of lifting the mind of man towards the mysterious expanses of the infinite," end quote. And here we have we are on the very last page of the book. Clearly, there is a Nietzscheanism here, and he continues, quote, "We seemed to have reached the extreme frontiers of the world and of life," end quote. Here is a hint of the physiologist in Mosso. He's not just interested in extreme alpinism, but how extreme alpinism and the very limit of human life come together. On the very bottom of this last page, in quite an extraordinary footnote, in fact, this is the only footnote of the whole thing, so maybe an endnote, Mosso, the physiologist, finally appears, claiming that, quote, "In a forthcoming book on fatigue, I shall present the physiological researches and experiments that constituted the principal aim of this winter ascent," end quote. As if physiology must hide itself amidst the literary flourish of mountaineering narrative. It is in this book, Fatigue, of 1891, that he had promised to explain in physiological terms his Monte Rosa ascent, which must be an extremely fatiguing experience, except that he didn't. Throughout this book of over 400 pages, with discussions from the fatigue of migratory birds to that of human muscles and the brain, to the mental fatigue of paying attention, he surprisingly made zero mention of his high-altitude research. And this deliberate omission, as I would like to show in the following, has to do with architecture. Specifically, he was waiting for one building to be built, which was under construction when this book was published. This building, the so-called Queen Margherita hut on the summit of Ponte Nifeti of Monte Rosa at 4,559 meters, the highest building of Europe even today. Built by the Italian Alpine Club, it perches on a narrow platform of rock formation with a vastly open expanse of view upon glaciers and snow, exactly on the national border between Italy and Switzerland. As you see, the border line is this red dotted line indicated here. That's Ponte Nifeti, where the hut was built. It was named after Queen Margherita because the Italian queen, who was, by the way, also Turinese, was among the hut's patrons and who, in fact, made it all the way to the inauguration ceremony of her namesake building in 1893. And behind this daring initiative, its design, its financing, its construction, are all the sellers, including Alessandro Sella, who climbed with Angelo Mosso. Again, a marriage of nationalism and alpinism that should not come as a surprise. Perhaps what merits more attention here is the other part of its name, Cabana Osservatorio, hut, observatory. which was quite consistently how it was called in official documents from the very beginning. That's different from all the other alpine refuges built by the Italian Alpine Club, mushrooming among the Italian Alps. Which is to say that the building was imagined to be double programmed, simultaneously a shelter for alpinists and the observatory for scientists. The hut observatory's purpose was to, quote unquote, to serve science and alpinism, with science even coming first. And by science, they mean multiple things at once, but what truly stood out from the beginning is meteorology. An incredible document in this regard is a long essay by Francesco Porro, an astronomer and director of the Torino Astronomical Observatory in this Filippo Giovara designed Palazzo Madama in Turin's city center. And you can imagine urban light pollution already been a problem for astronomers at this point, who wrote this piece at the bulletin of the Italian Alpine Club in 1890. When the hut was still under construction. And he simply titled it Hut-Observatory, not even the Queen. And endlessly, it's about the weathers, especially the bad ones. Quote, storm clouds, electricity, hail, St. Elmo's fires, cyclones, tempests, so many subjects of new and original scientific research, so many sources of vivid and powerful emotions, so many occasions for contemplating at close range under exceptional conditions, and all in all, the titanic clash of the elements, end quote, and so on and so forth. About his own discipline, astronomy, he spoke much less. But at the very end, he did mention Mosso, saying that Mosso could research, quote, on human breathing in the high mountains, on fatigue in ascents, on the possibility of an acclimatization of the human body in an extraordinary environment, end quote, which Mosso did soon after the hut was built and published his Physiology of Man on the Alps in 1897. We will come back to Mosso in a second. But here, Porro's conclusion is that, quote, this is manifestly not an ordinary shelter intended merely to facilitate ascents, but rather open to various categories of persons of the club. That is, it has to be inclusive and multi-purposed, quote, promising an unparalleled complex of aesthetic and intellectual satisfaction, end quote. But and what does this inclusivity and impurity mean architecturally? Well, for one thing, the site was extremely narrow. It is a wooden hut of 3 by 9 meters with just 3 rooms, a kitchen, a dormitory, and an observatory. So really, really simple. And due to the challenging weathers, quote, the small building must stand against the 3 most terrible elements at such a height: cold, wind, and lightning. The building as a whole must be firmly joined together, end quote. And in terms of binding the building together, the strikes of the lightning on the summit are so dangerously pervasive that the hut must be entirely cladded with very thin sheets of copper. And, quote, by entirely, it means not only the roof and the vertical walls, the door and the window shutters, but also the underside of the floor, and tied to the mountain below with braids of copper wire. So literally, it's roped to the mountain, so that the cabin would become one closed lightning conductor, end quote. Again, if we think about the hyphen between the hut and the observatory, it really has to hyphenate these 2 things into one and onto an extremely volatile ground. And exactly about this hyphenation of these 2 words, in 1893, upon the hut's completion, Francesco Porro authored another piece addressing Alpine Club members, much less optimistic than the previous one. He wrote that, quote, it is wise to bound the word osservatorio to the word cabana so that science could take some advantage. But when the hut was completed, Those who climbed up to it found nothing but a modest, bare-walled room added to the two intended for a kitchen and dormitory. There was almost general disappointment. As a campana, it is too much. As an osservatorio, too little. And he continued, here. And he continues to challenge his own inclusivity point. Quote, granted that meteorology is, among all the natural sciences, the one which will derive the maximum advantage from our station, is this perhaps a sufficient reason for the station to become exclusively a meteorological observatory? And let it be noted that the word exclusively is not here an adverb of rhetorical amplification. It is used in its literal meaning because a space of 3 by 3 meters with a modest collection of meteorological instruments suffices, alas, to exclude every other instrument, end quote. He's warning here that what was intended as an architecture of inclusion may turn out to be its opposite. Indeed, what is a hyphen if not an impossible union? As Jean-Luc Nancy puts it, quote, this coessence puts essence itself in the hyphenation, which is a mark of union. In French, hyphen is literally the trace of union, as in Italian, tratto d'unione, and also a mark of division, a mark of sharing that effaces itself, leaving each term to its isolation and its being with the others, end quote. My suggestion here is that the hyphen between cabana and osservatorio, with that rope between an alpinist and a physiologist coming to mind, impossibly binds what would otherwise be multiple epistemic and architectural conditions into one. And by the same token, the hyphen reveals that programming destinations like cabana and osservatorio really mean nothing unless being mobilized in one way or another. Contrary to Pauro's warning, Mosso subsequently made multiple attempts at stabilizing the hut as a permanent observatory and managed to systematically enlarge the building around the turn of the century. He did try to isolate the observatory from the alpinism shelter, but it turns out to be practically unfeasible due to lack of solid ground, only to further elongate the already narrow hut, resulting in an enfilade kind of configuration. He eventually abandoned the hut and separately built a mountain laboratory of his own at Kodolin. In 2 decades, the union gradually turns into division. In a bitter open letter of 1922, the Italian Alpine Club accused the meteorologist for privatizing the space at Campana Margherita for years. In one architectural plan with which the alpinists illustrate what to them a disgracefully unfair situation, the word exclusive strikingly appeared 4 times to denounce the meteorologist for privatizing the entire blue area. I mean, it's my blue area. Here, the wayward journey of a hyphen comes to its own backfire. The rope does unite when a severe exterior reduced the hut back to its primitivity as nothing other than a shelter from the elements. During the last time that Mosso stayed at the Margherita hut in 1904, he recorded a furious blizzard where, in order to go out to get ice for drinking water, the stationed alpinists and the physiologists have to hyphenate with each other with a rope, like what he did with Alessandro Sella in that winter 20 years ago. I'll stop here and thank you very much for your attention.
So thank you to all the speakers for such a generous session. I have so many questions for your presentations, And I would like to start with a general comment. I think the contributions approached architecture through a series of experimental conditions, houses imagined as autonomous systems, buildings conceived as scientific instruments, towers transformed into landscapes, laboratories exposed to extreme environments, ecological design practices based on open systems, and infrastructures that mediate between earth and atmosphere. So what connects these papers, I believe, is a shared interest in architecture as an active field of relations. In the cases we've seen, architecture produces knowledge. It negotiates between environmental forces, it reorganizes energy and matter, and responds to pressures that are social, technological, biological, and human-driven. This session, I think, it invites us to think about architecture as a medium for experimentation, a way of testing how we inhabit the planet, how we measure it, how we transform it, how we dwell it, how we might respond to unstable condition of the present. So I would ask the presenters to come here and have a seat at this table, and then we can start with the questions and the final debate, starting with Max. So for Max, thank you very much for your presentation. I think one of the most interesting aspects is the way you frame this autonomous house, not just related to the categories of the ecological design or energy-saving experimentation, but you frame it as a more complex project, shaped by a wider set of anxieties about overpopulation, urban growth. So this kind of planning freedom is the Pike is looking for. I was not familiar with this project before, but I know that there are some experiments related to the same topic for the following years. The first project that come up to my mind is a project by Renzo Piano at the Vitra Museum, but also I think there's another similar prototype by Fuller and Foster. So this project somehow suggests the idea of the architectural autonomy, and somehow it has never disappeared. And I was wondering if this experiment also, as you said, I mean, at the beginning of your presentation, you showed this part of the prefabrication, and I asked myself, is this an experiment? I mean, what is the purpose? Does it want to achieve a model or a prototype? No? Because somehow today I can still see the same concerns for the environment, the energy autonomy, the off-grid living, climate adaptation. So how should we understand this experiment? Does it offer a precedent in terms of sociality? What can we still learn from this episode, and or was it just a standalone project?
Yeah, cool. Fantastic questions and wonderful summary. So yes, thank you for that. With regards to the kind of like point about prefabrication first, this is one of the things that I found most fascinating about the project. Because in the late 50s and the 60s, there were a lot of experiments conducted with prefabrication, industrial building, particularly like open system and systems building as well, which relates to several of the other talks actually. And what I found so exciting was this kind of like this meeting of kind of prefabrication industrial building with like ecological thought. This was, and this is something that I don't recall seeing much elsewhere. But to go to your kind of a main question, yeah, how should we understand this project, given that there are so many kind of resonances with architecture today? And of course, this is a question I've been asking myself, and it's not a question I think I have a definitive answer to. I certainly don't have a definitive answer to it. But one of the ways I think it through, perhaps, is I still think the question of population, as it relates to the question of architecture, is massively important. And it kind of goes both ways. On the one hand, you have like an increasing flurry of books, which are forecasting global underpopulation. The idea that we increasingly dependent population, that the population is going to go into decline, and we're going to have, the inverse crisis of that which was forecast 50, 60 years ago. And yeah, and at the same time, you have concerns about, despite this context of kind of like underpopulation, like countless countries, probably more countries than not, are worried about over-immigration. So you still have kind of like floods of people, like the perception of floods of people into countries. And one of the places that this pressure is at least statedly most felt is in housing crises and in the occupation of urban space. And in this sense, I think that this project has a lot to say with both. And I don't think it's a direct lesson per se, but as I would say, as we see architectural projects that are responding to these contexts, to really think through the manner in which they are not just responding to these problems on their own terms, but the ways in which that they imbibe popular sentiments, popular anxieties, in the manner in which they engage these problems, or stated problems.
Okay, thank you for your reply. Do we have other comments from the other presenters regarding this presentation? No? So thank you very much, Max. Thank you. So we can go to the next one, Clemens. Hi. So thank you to you as well for your presentation. And I think one of the most interesting aspects was the way it shifts the discussion of scientific architecture away from the building as a neutral container for research. In the cases you have showed, the one in Japan, the one in Italy, I mean, the architecture itself becomes part of the scientific apparatus. It makes visible phenomena that are otherwise not visible, invisible. So in this sense, the building is, as you said, the building is the experiment. So there is a kind of identity between architecture and the instrument. So I would like to discuss with you more about this non-human intelligence that is manifested inside the building as part of the building, as maybe what we can call a historiographical category, capable of changing somehow the way we write the history of the buildings or the scientific and infrastructural science. So in this sense, the building is a medium between human and non-human. And my question is, can it become central also for other typologies? Because if the answer is yes, as I hope so, perhaps this question becomes more and more urgent today. because many of these sensing, measuring, and responsive technologies are no longer confined just in the scientific infrastructure. They are increasingly entering into the domestic space. So smart homes, environmental sensors, automated systems, energy monitoring, AI-based devices embedded into the buildings. I believe architecture is becoming more operative, more responsive, and more involved in forms of non-human cognition. So I would like to ask your opinion about it.
Great, thank you. Thank you so much for the really interesting and astute summary and for the question. And thank you all for bearing with me while I was trying to play around with this idea. And like in the beginning, I got like really focused on like making this like alien Earth, like kind of like work, and like I knew that there's something in there, and like the strangeness and the weirdness that etymologically Tyran so astutely parsed, and there's a lot in the hyphen in connection to the disconnection, I guess, as well, that one could think about and through. And I think you already in your question kind of pointed towards the point that I think interested me the most about this problem, let's say, of non-human intelligence, which like a lot of computer scientists in recent year and a half maybe, I'm thinking of Blaise Aguirre-Iarcas, who wrote this book like What is Intelligence so recently. It's like a very fascinating book about how evolution kind of can come through like non-organic entities as well, and how the similarities between computational entities and biological entities, and once you like read this and like see these comparisons, you can just like not stop thinking about it, like at least I couldn't. And so I wrote this book with a couple of political theorists about like what could like a modern human kind of like planetarity and kind of like relationship to the planet look like, and that's where like all these ideas of like the modern human kind of came in. And I'm totally believe that architecture is astutely equipped to like basically step up and negotiate more between like the modern human entities and the human entities and the non-human entities and agencies that kind of make up our planetary condition, as we call it. And I kind of like call it like loosely a little bit the problem of the hard architecture versus the soft architecture, whereas the hard architecture kind of has its relationship in the modernist discourse and like its envelopes and its containers and kind of like environmental mediation between an interior and an exterior, and the soft architecture kind of like posing a little bit more of like the software edge of it. And I like to cite Andrew Witt, which Anna also cited, who has like this really interesting paper, and I think it's an architectural design, which is called AI, Alien Embassy, basically, and it kind of like thinks about the whole N-Farm Dolphin Embassy situation, which was a project in the 1960s, 1970s, about kind of like creating this kind of like an architectural structure that can mediate between two different species, like human researchers and cetaceans, so dolphins, who can like meet in this architecture that is both floating on the ocean, like allowing dolphins to swim in, and the researchers to kind of like each species and each participant basically in that conversation to enter from their own environment, or like their own natural environment. So Witt writes about this kind of like how AI and like more technologically advanced softwares or like soft architectures can like become like nowadays like more of the intermediary between maybe non-human entities and their communication. And we see it a lot in different bioacoustics research, for example, where researchers are really playing a lot with like AI, large language models, and these kind of like different aspects to try to understand cetacean languages and cetacean communication. And so yes, I definitely hope that architecture can step up. And although like my paper today was of course a little bit polemical, I think there's certainly something in thinking architecture like from a non-human perspective. Yeah.
Thank you for your reply. Do we have other comments?
Well, Clemens, I mean, thinking of your presentation among this lineup, it's quite evident to me that your work is a bit further on the edge, in the sense of, I mean, thinking also about even your personal affiliation. It's really the more, I mean, whatever it means, interdisciplinary. So I think it's a good opportunity for us to reflect a little bit on that. I mean, in your presentation, there's a moment you almost self-inviting and a reflection about whether architecture is, how much of it is welcomed into the field. So in addition, other than thinking about the things that you already mentioned, political ecology, infrastructural media, geological media, elemental thinking, infrastructure studies, etc., etc. So I think I'm interested in asking you to reflect a bit deliberately on your relationship to this field, to architectural history. And I mean, in your presentation, you gave a more rhetorical way to respond to that. But I wonder how you are confronting this. And I think that that also speaks a little bit to my own work, but I'm curious about what you think.
Thank you, Tyran. Tyran and I know each other quite well. We were for years and years like in the same institutions. We lived together, so like that's why this question hits like especially hard. No, but it is true. And like I find myself always drawn to these like interdisciplinary collaborations, and like I'm working like an interdisciplinary research center that focuses like on the humanities at large. And I find like architecture is such a fascinating discipline and field, especially for that, because I believe like architecture is inherently interdisciplinary, because it is engineering, it is humanities, it is sociology, it is psychology. It has like all these different aspects like built into the discipline of architecture. And for my dissertation, I wrote basically an architectural history of geophysics, of modern geophysics, and like its colonial project and imperial Germany in the South Pacific, for example. And so already there, like I was trying to like really push a little bit on the boundary of like what architectural history writing could be, in a sense of, like at the intersection of the history of architecture, science and technology, which are extremely interlinked and like entangled, in my opinion. And what I always found like really interesting about that is what I encountered, like as we've seen today a lot, which I'm like actually really, really happy about to see in the symposium, is that a lot of these architectures don't have the big names like pinned down. They're like not the big architects, it's not capital A architecture, it's like lowercase a architecture, usually and like massively impacted and like designed by the demands of the scientists involved and the creation and design and foundation of these different laboratories, observatories, experimental laboratories, etc. And that's why I'm like trying to, in my own practice, in my own research, in my own, try to push a little bit back on that and like really maybe rethink architectural history from that position. But I still believe that our field and has a lot to contribute to like the larger bridge building, I like to call it, between like the humanities, or like the planetary humanities, which has become like kind of like a field in recent years, and the planetary sciences. So that's what I'm working on right now in a new project that kind of like deals with these places of planetary sciences and space history and space analogs, basically. I hope that was to your satisfaction.
Thank you. Any other comment? Okay, thank you very much. So next one is Joseph, and thank you very much for your presentation. I I really appreciated from, I didn't know this project by Ferri, and the first thing that, probably the thing that impressed me the most was this idea of inserting a native natural landscape into the nest of capitalism, which was New York City at that time. So it was not just a greenery as an aesthetic device, but much more a radical reintegration, as you said, of architecture and nature, where the skyscraper becomes a kind of ecological system and a public landscape at the same time. So in this sense, I was wondering, because this project, as you explained, it seems to work within the logic of Manhattan. So it's a building actually designed, drawn for a corporate. It works inside this dense environment. It works with the logic of the real estate value, verticality. So it's playing somehow the same game, but it's trying to change the rules, as it is proposing this very provocative solution. I enjoyed the drawings. I was wondering if you can say something more about the relationship with a super studio, since I don't know what kind of connection there can be underlining these two firms. And at the same time, I think the drawings showed how this entire landscape is merged with the building in a very experimental way. It made me think to the artist Gilles Clément, which is trying to push, who has tried to push this idea with some land works. And when I saw the building for the first time, it made me think to exactly the project you showed from Big. I don't know if it is the one in Singapore with Carlo Ratti or another one, but... No, that one okay, okay. So there is another one which is very similar in Singapore, just designed, and it's trying to expand this same idea of having the landscape. Probably they dedicated more space to the landscape and nature than the one you showed, but the concept is the same. So these, let's say, green towers today are very recognizable, and we can see them a lot in our landscape, probably more as greenery, as I said before. I have one example in my mind that I don't say loudly, but you know which one I am referring to, probably. It's close to you. And so my question is, what today's designer can learn from this radical project? Because you have showed one project as a comparison, but since we are definitely going the direction of designing more in this way, what can we learn more? I have a reply, but I hope it's the same, the one you will give me. No, later.
Well, thank you. Yeah, well, I mean, no, I'm trying how to synthesize my answer, because actually I think that your comment is really aligned and appropriate, and actually I could develop like quite lengthily, maybe more about some points than others. But basically, I mean, the way that I understand the project, the project and the drawings that I showed. Actually, I presented, of course, the project in a very directed way towards building some interpretation, a specific interpretation. I didn't, because of the time, deepen that much, like in the contradictions, for example, because of course it's not a real project. It's a conceptual project, as I guess that everyone understood. But it somehow plays with this logic of Manhattan in the way that Rem Koolhaas does, like taking that lot in the city, and then developing like the mass according to regulations in New York, and building regulations in order to maximize the profit. I mean, it's the same logic, but then it adds these ecological aspects that I was mentioning that I found really fascinating since the first time that I saw the project, which made the project completely unfeasible and unbuildable, basically because of course we move always between research and the conceptual explorations, and then when we try to build things we are confronted or we are crushed with reality and with building regulations and with all of these things. And I think this is something, it's a very important aspect to consider because at the end Ferry's project is really exploring something which is it's somehow new in architectural debate, and it's very pioneering in those years, but actually not that much, because if you think very close to that project, there is Central Park by Olmsted, and Central Park is completely artificial piece that was designed basically using very similar principles, because when you look at all the British picturesque debates are very much like moving between science and humanities. So it's basically philosophy, literature, science, and mobilizing all that knowledge to design something completely new. This is something that Olmsted did in Central Park, and somehow we could undermine a bit this project by Ferry saying this is like extending that into a building, which from that point of view maybe conceptually is not so original, and Olmsted was like 100 years before. So so I think that's interesting, and that links with with the point that you were making about green towers today, that they have become very popular. They have become very popular because finally we are understanding, for example, the public is understanding the comments that Ferry was making in the 1980s. I mean, reading this text by Ferry from the 1980s today seems like something very like contemporary, but actually, I mean, it's going to be very shortly 50 years ago. 50 years ago, and I think that this reveals part of the conceptual problems, because if we trace greenery in high-rise buildings or in towers, if we look back to modern architects, Le Corbusier was putting plants in balconies in many towers. So we have, I think that all of us, we have in mind like the tower buildings by Le Corbusier with big balconies and a lot of greenery. The difference with Ferry is that in Le Corbusier, in early 20th century, there was still this understanding of nature as a warehouse of resources. There was not a real ecological understanding. And in Ferry, we acknowledge that switch in the understanding. There is an ecological understanding. And I think the problem that we find today, and it's a very serious problem, and I think in this sense the discussion moves towards professional issues rather than theoretical issues, is that our knowledge and our thinking is very developed, but we we cannot really implement it because I think the idea behind green towers today is that they really want to work ecologically, but very probably, I mean, it's not that I want to defend those architects because of course I mean, we could try to develop further like the criticism of those projects, but I'm sure that there are very much a lot of limitations that are imposed by building regulations. So maybe just to close the intervention, because it's not that I want to extend a lot, I can explain an anecdote that I think it's very fascinating when. That I found myself involved a few years ago in the UK, because before Milan I was based in the UK, and a group a group of my colleagues, they were awarded like a massive research grant. I think it was the biggest research grant that it has been ever awarded to an architecture project in the UK. It was basically something like, if I remember well, it was around £7 million. So it's a lot of money. And the point that my colleagues made to get that money and to be awarded that research grant, I think it was great, because it was basically, we are doing research in architecture, and in order to test our ideas, we need to build a building. So basically, we are asking the money to build a building. And everything was about the use of living materials. So biological materials and things like that. And of course, then we identified a place in the university to build this laboratory, let's say, or this building to test biological materials. And from that moment on, everything went downhill. Because, then we had to face the university administration. And the university, of course, said, of course, we are building this on campus, but since it's a building and we are in a city, we must comply with building regulations, because otherwise insurance don't cover, and this is not contemplated in regulations. And, then when you go and you say, look, we are not going to build foundations here because we have this bacteria that we put it in the soil, and then this compacts the soil, and we don't need foundations, then of course people look at you and say, yeah, but regulation says no. So I think when we do this criticism, we must also be aware that unfortunately, again, it goes about politics, because sometimes in order to really be able to push further these things, we need that politics is in line to change regulations when needed. But well, I don't want to to discuss more. I don't know if it's aligned with what you were thinking.
Yeah, I can tell you later actually. So if we go on, but it's very similar to what you said. Yeah. So thank you. Do we have other comments? Okay. So thank you very much. So, Anna, thank you very much for your presentation. And one of the most interesting aspects was, in my opinion, this very close comparison between Knowles and Hilbert's. Has two figures who both refought completely architecture through these ecological concepts. Knowles seems to approach the environment through natural forces, planning tools, more to spatial relationships, so implementing concepts or natural elements as sun, wind, water. And Hilbert's, on the other hand, moves towards a material process and explores this idea of constructing with non-human organisms. So two different case studies, but at the same time, it has been super interesting to see them connected and compared. I think they both suggest a shift from architecture understood as a closed and controlled system to an architecture understood as something embedded within a more dynamic environmental process. So they represent two divergent trajectories within this macro ecological design culture. So from today's perspective, how do you think contemporary architecture is positioned within these two authors? Our current architecture panorama, both in terms of research and practice, in your opinion, genuinely learning from these two experimental paths as open systems? So So are we somehow, how are we working nowadays into translating these researches in a more controlled and practical paradigm of ecological design?
Great. Thank you so much for the question. This is something I've been thinking through as I'm continuing to work on these case studies, and I'm kind of thinking about it on two different levels. First, I'm really interested in looking at how we can see the legacies of this kind of research, both in models and in sort of the output of the research. I think we do see even more laboratories of different kinds today in architecture schools and firms. And there's also the question of how both of these architects influence specific tools that are used or ways of thinking. Knowles's work, I think, has influenced simulation software in different ways and different strategies toward zoning and regulations. And Hilbert's, the system that he patented continues to be explored in some ways, but I think maybe the bigger influence is more so on just sort of alternative approaches to fabrication and working with existing ecosystems. So I think that's sort of one level, and then on the other level, I do think that today, a lot of the time when we talk about the influence of environmental science on architecture, it's more, there's a greater emphasis on sort of standards or ways that knowledge can be incorporated at certain points in the process, which is both very practical, but also I think there was this moment of exploration kind of in the 70s, 80s, 90s, where some of these designers were really trying to restructure the process of design much more radically. And I do think that these designers have been studied somewhat, but I think they're still somewhat lesser known in comparison to earlier figures like McHarg, as was discussed. And I do think there is something to be learned from these projects, although they're also very complicated and need context to look at. Yeah, thank you.
Thank you. Do we have questions?
Thank you, Anna, for your really amazing presentation. And it was really nice to, I think, pit Knowles and Hilbert's different processes of the open and closed system against each other, and like to read them through that lens and comparative lens. And I want to push back a little bit on this idea of like cyber texture and like what your opinion on that is, because I find that really interesting. I think in the beginning you said it like this presentation is about dynamic construction or something like that, or Hilbert's and Knowles were concentrating on dynamic construction or something like that. And I was really struck by this, like, you know, like the open system versus the closed system, and like it reminded me of like what the observatories or like these these instruments as architecture's instruments that I was discussing are doing. They're filtering, you know, and like I wondered where maybe this idea of the filter come in, or like other kind of like cybernetic tropes that kind of like were circulating at the time.
Thank you. Yeah, I definitely do think that the way Hilbert's was imagining cybertexture was both very strange. It was sort of this metaphor that allowed him to talk about existing industrial and technical processes, but also to sort of imagine architecture as being closer to biological systems. And I do think that there was very much a filtering function to it. In the mineral accretion experiments that he did, he didn't sort of continue to always connect it back to cybertexture, but he did actually do something very similar to what he had diagrammed, and there were computer sensors involved to sort of measure what was happening. And yeah, but I do think on a broader level, I was interested in that too with your presentation and your framing of the idea of sort of filtering or withdrawing, because I do think that in Hilbert's especially, but also in Knowles, there is some sense that to sort of intervene in a very complex and changing environment, you do have to focus on certain aspects of it, and I think that is a very different approach to the sort of imagination of a closed system, whether it's a building or something else. But I'm not sure if that exactly answers, but yeah, thank you.
Do we have another question? No, thank you very much. So Tyran, last question for you. Thank you for your presentation. And I was impressed by this aspect of Capanna Margherita, which is the convergence of a very particular architectural, let's say, characteristic of the building. So it's a laboratory which is internal and external at the same time. Thanks to the environmental condition it is positioned within. So in this sense, the laboratory extends its nature beyond its typological reference as an enclosed space. So it's not simply a controlled interior, but at the same time it receives influences from the nature that surrounds it. So this hut becomes a place where the altitude, the atmosphere, the three enemies that you mentioned before, which were cold, wind, and lighting, sorry, converge. So I mean, everything is fought at the same time. So it's super interesting, this aspect of the copper and the Faraday cage. Regarding this typological question, so the hut seems to challenge the modern idea of laboratory, as I said, as a controlled interior. So would you say that this experiment represents somehow an alternative genealogy of the laboratory based on exposure rather than control? So a more active and responsive space where you can do experiments. So, and I would like to hear your opinion about it. And yes, since it seems to challenge this conventional image of the laboratory. And yeah.
Thank you. That's a wonderfully framed comment and deeply thoughtful idea to think about this. I mean, they did not use the word laboratorium, although they do believe that a lab should be somewhere established. Eventually, it was established a few years later in Col Dolan, which is at 3,000 meters. So somehow they believe that while it is intensely interesting to be up there as high as possible, the controlled interior of the lab is absent, and they found it to be problematic, and that's part of the reason why, from a factual perspective, why they eventually abandoned that site for science and moved it down to a bit milder kind of environment. But that's on the level of facts. But on the level of your question, which is, I believe, has to do with the historiography of high mountain science and historiography of high mountain architecture, I think I have maybe just two quick points to make. First is that I found the word laboratory interesting. It's the place to labor, right? So, I mean, the word in its early modern usage never really means anything close to science. It's really somewhere you intensely do your work, and really has to do with how facts were produced. Now, facts, as we know, fatto, it's a thing, right? It's a thing you do. It's really not something that's out there and you grab it, but rather it is something that you produce in labor. So that's always something I found interesting in the history of laboratorium as opposed to laboratory, which has to do with, as you were suggesting, a new frame of references, a new frame of historiographical concerns that maybe let's step outside of the lab versus field kind of dichotomy for a second, as we realize that there is a lab in the field, there is a field in the lab. So that's point number one. And point number two has to do with your question about the interior and exterior point, which to me, I guess in my presentation, and also I'm thinking about how the interior was part of, I mean, it's part of the facility as much as part of the problem, just like the outside. So, I mean, one of the reasons they want to be up there is that they found it to be scientifically exciting, both for the alpinists and for the physiologists and for the meteorologists, even for the astronomers. And yet, I think what I found to be interesting in this case is that whole intense meteorological and astronomical condition is at once the object of concern, object of scientific concern, and the object of disruption. So architecture appear there somehow. I mean, whoever would use that space has to deal with that, whatever that means. You know, being in a facility, studying something that at the same time is the artifact, at the same time is the disturbance. You know, you have to keep your building stable. You have to keep away from being blown away down to below, etc., etc. So which maybe relates to your first point as your first part of the question as well. That part of the complete promiscuity of architecture's relationship with the elements. I mean, in terms of its scientific value, is what interests me throughout perhaps other parts of my work as well. So thank you for your thoughts. And in general, I think that it is, yes, alternative genealogy. And it is a kind of responsive architecture that has to do with, as Clemens pointed out, that architecture is not a container, but what makes knowledge happen. So that's also part of what I'm doing here as well. But just quickly, I want to mention one book that I recently really found fascinating is by Philippe Felsch, this historian of science, who wrote a book called Lab Landschaft. And I found it fascinating that even in the title, it's a complete redesign of what laboratory could mean, and of course, what does it mean to be labor in the landscape? I'll leave it there.
Thank you very much. Do we have another question?
Thank you so much, Taran. Also, thanks again for that really beautifully written and narrativized kind of connection between the weird and the wayward and like the hyphen in between. And I have a question a little bit to the point of nation building, because that's prevalent in your dissertation research, and it's like prevalent also here, like in this presentation. And I wonder if you could say something about whether, I kind of observed it in the German context, that it's usually extreme environments that kind of devoid of human presence usually become kind of these places and spaces, environments where nation building can make a certain special or more impactful claim. So I wonder maybe in this paper or in this project, this topic of this kind of this idea of the extreme, devoid of human presence, devoid of any biological presence, at that altitude, if that's kind of comes into play at some point.
Thank you, Clemens. Yes, absolutely. And alpinism seems to be a good place to think about that. I mean, your question reminds me of how parallel these histories have been, and if we think about the formation, I mean, Germany and Italy, their parallelism is too strong. But even if we think about somewhere that's less parallel, somewhere like France, somewhere like Switzerland, it's almost exactly the same kind of alpinist discourse, and which has to do with everything everything you just said. That you build your nation at somewhere that's on the frontier, and the idea of the frontier. I mean, Italian the word frontier, the confine, right? So it's not only frontier but also boundary, and I found that kind of conflation very interesting. That almost you find your frontier only in the north. In that sense, I mean, I understand the southern question. I understand Sicily. I understand Naples. So just from that mountain climbing perspective, it seems to me that that's the only legitimate horizon. So that the right place to acclaim Italy is there. And I mean, think about Torino, how central Torino has been to the whole Risorgimento movement. That's something probably everybody in the room knows way better than I do. So I think there is something about an alpinist nation building project, which Clemens, you're absolutely right to point it out. But I want to quickly respond by speaking about the second side, the other side of this. That is, so the idea of national boundary. So, for example, the hut that I showed today, it literally sits on the boundary between Italy and Switzerland. By literally, I mean it really literally. So it's not until the 1950s did the Italians and the Swiss somehow resolve the problem. Like, where do we draw the line? If they draw the line across the building, then the building should be half Swiss. But somehow they figured it out, that the building, they shifted a little bit to make sure that the whole building, which has Queen Margherita's name, to be fully Italian. And that speaks to the point about whatever it means to be to have a natural national boundary. Because, I mean, as we know, the Alps being this classic place where the whole discourse of a boundary should be natural comes into play, which has everything to do with World War I, has everything to do with the Prussian-French War, has everything to do with the land conflicts. And one of the reasons is that they consider the ridge, the watershed, to be something that we take for granted. But the many exciting recent work take that up seriously by arguing that what about glaciers? If glaciers move, what does that mean? Does that mean the national boundary move? And also the very exciting work about global warming. So exactly. So those environmental variations kind of comes into play to Clemens, your question. And the only case that I find less clarified in existing scholarship, maybe just beyond my knowledge, is that the case of Austria. So Austria is a bit strange because if we think about Austria's boundary demarcating, it doesn't really fully agree with the watersheds, and they have developed their own theory about whether a national boundary should be the watershed, or actually, according to the Austrians, they believe that they understand the nation to be established upon a pass, upon a mountain pass, in the sense that the pass belongs to a nation, not the watershed dividing territory. So again, I use this example to illustrate how artificial all these nation building projects has been, and your question is absolutely legitimate. Thank you.
Yeah, I would like to add something to this, because actually I've done some research about national building processes, and actually had a comment related to this with your presentation. Because I think that more than the extreme condition or things like that, regarding national building, it's more like the weird and the strange thing. Because basically it's upon the study of the unique natural formations that you can define your national identity as opposed to other national identities. Because national building in Europe happens hand in hand with the emergence and spread of natural sciences, and actually a very important part of it is the scientific exploration of the land of the nation. And in that sense, when you were doing your presentation, it was constantly coming to my mind some of my own research on Montserrat. I don't know if you know Montserrat. Montserrat is this very strange mountain close to Barcelona. It's a geological formation which is really unique, very weird. Actually, it became a symbol for the German Romantics. Even Goethe and Humboldt discuss about that. And the mountain belonged to the Catholic Church, and it was expropriated in Spain when Spain was struggling to build itself as a modern state like the rest of European countries. And there is a moment in which there is a lot of discussion and debate about the scientific exploration of this very strange geological formation. And at the top of the mountain, they built an observatory. And it was something really, I mean, it's something that you could put very in parallel to the case that you explain. But in that case, it was not like a Capana Observatorio, but it was a Temple of Science observatory. And the Temple of Science was very funny because since there is a Madonna, a Catholic Madonna known as Rhine, very famous there, and the Catholic interpretation of the mountain was very pressing. There was like a competing scientific explanation of that, and actually that tension was used to turn that into a national symbol. But there was always this competing scientific, religious thing. And the idea of associating the observatory with the Temple of Science, which was actually, like in your case, in the top of the mountain, made that that became like a battlefield between science and religion, up to the point that the observatory was very similar. The difference is that the geometry was an octagonal room with one window on each side, and then very quickly the church tried to appropriate this Temple of Science by putting a gigantic statue of a Christ on the top of the Temple of Science. And then because it became very touristic, because it became a national symbol very quickly, then many restaurants opened around. And then they combined the Temple of Science with the religious temple, with restaurants. And then popular publications were making jokes like there is nothing more pleasure than eating this awesome food with this amazing view. So, well, this is just to say that I think that when the national identity component is brought into the discussion, I think it's a bit more complex, and I think it has more to do with weird things, with the unique aspects that basically are the ones that national building processes can mobilize to define identities that oppose to other identities. And I guess that the case of the Alps is very unique because actually it's a very unique geological formation that's shared by different countries, and therefore it's a territory of competition also at that level. And in that sense, from the publications, the Viollet-le-Duc, I think it's the most fascinating one to me, but we can discuss.
Thank you very much for the discussion. Do we have a question from the audience? That's it, okay. So I close the session. Thank you very much for your presentations and the time we spent together I think this session has brought together very different cases, even if they all point somehow towards a shared concern. Architecture as a practice that operates within complex systems of nature as matter, energy, knowledge, life. So we have seen how architectural projects can respond to crises, register invisible phenomena, construct ecological imaginaries, engage unstable environments, and open new relations between human action and non-human forces. We have seen how to reconsider some familiar categories, typologies, and I think this session, at the end, it invites us to think about architecture as a medium of experimentation, a way of testing how we inhabit the planet, how we measure it, how we transform it, and how we might respond to unstable conditions of the present. So thank you very much to all the speakers, and congratulations.